Hi everyone, my name is Nathan Yates and welcome to the Tech Services 2020 Fall Lunch and Learn. Today we're going to be talking about FER, and really this is going to be just a refresher from last year's Lunch and Learn. What we're going to be going over is some blower charts and along with blower setup and some of the boards that you have seen over the past year. And remember, going through this presentation, please submit questions that pertain to this FER topic, and we'll get to those at the end. So let's dive in here. So what does FER stand for? FER stands for Fan Efficiency Rating. This took into effect on July 3rd of last year, so 2019 is when FER took into effect. So for us as a manufacturer, any furnaces that were made July 3rd and so forth had to be FER compliant. So the main thing is that the furnaces that were affected were the single stage stuff. So you went from a PSC blower motor to a fixed torque ECM. And also too, I just want to put in here that air handlers were not affected during this FER setup or this FER change. The main reason for this is that the regulation deems that the primary heat source for an air handler is a heat pump. Even though you may also have a heater kit in there, again, they designate as the heat pump as the primary heat source. So with our air handlers that are available to you guys, the B6B MMO and the B6B MMX, those model numbers will still have a PSC blower motor in that unit. So what did we have to do as the manufacturer? So a couple things. One, we actually had to then go to a fixed torque ECM motor, and then we also then had to change the board setup a little bit in order to accommodate going from a PSC to an ECM. So what changed here? So hopefully throughout the whole year here, you guys have noticed these changes on the board, but I want to just point them out to you here. One change is that we had to add a red wire to bring 24 volts from the top of the board down to the bottom in order to output voltage to the blower motor when you have a call for cool or a call for heat. Pretty much everything else on this board stays the same. The other thing that I really want to point out to here is on the bottom of the board, we have changed from a 120 volt output to the blower motor like you would see on furnaces prior that would have a PSC blower motor setup to 24. Now, it's still a 4-pin plug. It does say 24 volts, so that does help you as far as determining what you have. But again, these are 24 volt outputs, and they are in correlation with your selector switches here at the top. So as far as how you select your blower speeds, those have not changed. So you do have your cool and your heat, and then you also, by a jumper, have your fan selector switch for a G call. So none of this has actually really changed as far as how you select your blower speed. Mainly it's just the output voltage is now more of a control voltage to the blower motor. Now, this board will also output voltage 120 volts to the motor. So it does both. It does your 120 for line and then your 24 volt in relation to your speed, depending on where your selector switches are. So that's kind of what's different with the board. A lot of it's the same, but those are the main differences. So again, the blower motor has changed from a PSC to an ECM. Some questions that we do get is, what kind of ECM motor did we go to? Well, what we went to is a fixed torque ECM. It's not a true variable like you would see on our 2-stage 95% furnace or the 96% furnace where you have the ability to go to a variable speed. The motor that's going to be in the FER furnaces is going to be a fixed torque ECM. So as a result, you will also then have no blower capacitor. ECM motors do not have capacitors, so that's one less thing that you're going to be seeing in the blower compartment. The blower motor has high voltage, which is 120 volts, and then it also has the 24 volts that's going to the motor in relation to what speed you want to be running at. Again, changing the blower speed hasn't changed, so it's by those selector switches at the top of the board here, as far as your 4 speeds that you have the ability to change on the fly. And then also the fan jumper call that's right next to your selector switches here at the top, that also hasn't changed. So that also follows your 4-speed selection from low to high for a G call. So let's talk a little bit about motor troubleshooting and how we troubleshoot the motor if you were to come up on a service call. The main thing is that you want to measure your line voltage. So you need to have neutral and L1, or in this case, L1A is the terminal on the board that then outputs that voltage all the time to that blower motor. So what kicks the blower motor on, you may ask? Well, what you need to have is also 24 volts going to the motor. So essentially, as long as you have line and low voltage going to the motor, you should be good. Now, if the motor's not running, what we may need to do is either check connections at the board or on the motor plug itself, or we also just may have a motor that needs to be replaced. But essentially, you want to have line and low voltage going to the motor, and your motor should be running. Here is just a wiring diagram of a single stage furnace that has the ECM fixed torque motor on the FER. The wiring diagram that you have here is pretty much not going to change. What has changed is this section down here as far as the actual blower motor. So what you have here on this motor is actually a 5-speed ECM tap. Now when you go to the board, this board back up, when you go to the board on these selector switches, you only have 4 speeds to select from. So you may ask, how do I get that 5th speed? So if you need to select the 5th speed or need to utilize that 5th speed on the blower motor, essentially what you'll do is down here you'll have your 5-speed taps. You'll have 1 through 5 here. You've got your line voltage, and then you also have your 24-volt common going to the motor. Basically, one of these 1 through 5 terminals will not have a wire on it. So essentially all that you have to do is unplug one of these wires and then plug it into what we deem as the alternate tap to that blower motor plug, and then you can utilize that blower speed. But essentially everything else that you see on this wiring diagram hasn't changed other than just the stuff that pertains to the actual blower motor. The other thing that I wanted to touch base on is that on the manufactured housing side, the single stage 95% furnace has this same exact setup that you see here. So say for example the G7SA furnace, this is the wiring diagram from the G7SA. On the manufactured housing side, a single stage 95% furnace will have the exact same setup that you see here. As far as the wiring diagram and how the blower motor is set up. When it comes to the blower charts, again, we have to separate per FER regulation between your heat and your cool blower charts. Before FER, we had everything in one chart as far as the heating, which we gave you a temporize in those older charts, along with the CFM number. Per FER, we have to separate that. So again, you're going to see a heating chart and a cooling chart. On the heating chart, the duct static pressure we range is from a 0.1 to a 0.5. So that's what we have available to you guys in relation to CFM and duct static pressure. And then on the cooling side, we have it ranging from a 0.1 to a 0.8, just as kind of the older blower charts that you're all used to. So mainly you're looking at 2 different charts, one for cooling, one for heat. The next slide that I have here is going to be a blower chart for a single stage furnace. So what I have pulled is from a single stage, which is a G7SA furnace. So that's what we have, your model number on the far left. The next column here determines where your return is. So you can either choose from a bottom, side, or side and bottom, where you have 2 returns. And then all that translates as far as what your CFM numbers are based on your return. You'll also see here in the blower chart is that we designate a alternate speed. And what that is the open tap on the blower motor plug. So if you need to utilize that tap, if you have depending on what your duct static pressure is and then what CFM level you're trying to achieve, you may need to use an alternate blower speed. So we're designating that as the alternate tap. That alternate on this one, for example, is tap number 4. Now, depending on other furnace models and BTUs, it may be like tap number 3 as your alternate. So it's always not going to be number 4 for your alternate speed. Also on this heating chart, what I want to point out are all these grade cells that you see here. So essentially, when you set up the furnace in relation to your temperature rise, you have to be within the numbers listed per your static pressure in order to be FER compliant. So we get the questions in tech is, can I use a higher blower speed? I guess in theory you can, but we in tech cannot tell you to do that because then we will not be FER compliant. And if the furnace were to be inspected and you were at a higher blower speed, for example, it should not pass inspection. So what you want to look at is, one, where's your return at? Also, you then want to take your duct static pressure, which on heat ranges from a 0.1 to a 0.5, and then determine where your temperature rise falls. And then we also give you a CFM number based on where you're at in this chart. So again, you want to just be within these white boxes as far as your temperature rise. The next chart that we have here is going to look very similar to you guys. This is your cooling chart. So again, you have your model furnace where your return is, and then at the top you have your static pressure ranging from a 0.1 to a 0.8, and then we give your CFM levels. Also too, you'll also have 5 taps here, and then again, the number 4 on this furnace model number is the alternate. So depending on where your static pressure comes into play and the tonnage of your equipment, if you have to use that number 4 speed, just go to your blower motor plug, unplug one of the wires from one of the speed taps, like you could unplug number 3, plug it in the number 4 tap, and then just set your blower speed by your selector switch on your board, and you'll have the blower speed that you want. So every now and then I'll run into that into tech service is like, I have this static pressure and I need this CFM because I have, say, a 3-ton unit, but it's the alternate. How do I get that blower speed? And that's how you go about changing that blower speed to the alternate. So now we're going to talk a little bit about the manufactured housing side. So on the manufactured housing side, the model numbers have changed a little bit. So I just wanted to point this out to you guys as far as what the old series or the older nomenclature is, and then how that translates once FER took into effect. Like for example, like the M1MB furnace or just the M1 series in general has been around for a long time. So when FER kicked into gear last year, that changed from an M1MB to an M1GE. And again, that is our single stage 80% furnace. On our other 2 series lines for furnaces, they have changed. So the M7RL changed the MG2R, which is that 95 single stage furnace. On the last one here, the M7TL, that really wasn't affected by FER because we already had an ECM blower set up. Just the model number changed on that. So, but I just wanted to make sure you guys were aware of the model update on that. And then this right here is just the nomenclature for the new manufactured housing side. So you can find this exact picture on the tech spec of any of the manufactured housing furnaces on our literature website. So again, just per our nomenclature, you'll have your series number, your efficiency rating, your BTU level. None of that really has changed other than just a number or a letter. But yeah, so this is the nomenclature for the new FER furnaces on the manufactured housing side. So now we're going to talk about the blower speeds and how it relates to manufactured housing on the single stage side. So we have your red wire, which is going to be your heat call. Yellow is going to be your call for cool. And then on your blower motor, you'll have speed taps 1 through 5, which are listed here. And these two pictures are pulled directly from the wiring diagram. And I've just blown them up for you so you can see them. So on the heat side, you do have your 1 through 5 to choose from. On the yellow side for your cooling call, you have 1 through 5 to also choose from. The last bullet point that I would just point out, just what I reiterated before, was you got to be FER compliant when you select your blower speed. So any cells that are grayed out, you cannot use that tap in relation to heat. But on the actual blower motor itself, you do have a white and a black for your 120 volts coming in, your 1 through 5 for your speeds, and you will also have a gray wire for 24 volt common on in relation to your 24 volt side on the blower motor. Right above me here, you have the main thing I just wanted to point out is that you have a C and an H terminal. That's on the bottom right-hand corner of the board on the M furnace, the single stage furnace. The C is going to be, and the H is going to be 24 volt output directly to the motor for either cool or heat. So the C is going to have a yellow wire and the H is going to have your red wire for the heat side. The other thing I want to point out is that how do we control just the fan only call? And the other calls that we get into tech is, what is this green wire that goes to the blower motor plug? Well, the green wire is your G call from the thermostat, or your fan only call. So by default from the factory, the green wire that you're going to see in the furnace is right on tap number 1. Now, you can move that green wire to a higher tap if you want to, certainly. But from us, at least, it's just going to be on tap number 1. And again, the green is just for a continuous fan only speed. So if the customer wants to just have the blower on to circulate the air through the house, that is the speed that you're going to select. This is another question that we get into tech a lot, is the yellow wire, or say your call for cool, for example, that what have highlighted here, that goes down to the G terminal on the board. That is correct as far as the wiring, because a lot of times we get questions in tech well, G is the fan only call, which is true in majority of cases, but on this board, the G call is actually going to be your call for Y, for cooling, on that. Or if you had a dual fuel application, it would be just the call for compressor. That's what I also tell guys in the field. Y is a call for compressor. So yes, just to reiterate this, is that your Y, or your yellow wire, if you will, going from your thermostat into the furnace, that will connect to the G terminal, and that is how it's supposed to be hooked up. Again, your green wire, like we talked about in the previous slide, that wire goes directly to the blower motor and it bypasses the board completely. And then what I have pictured here is the wiring diagram on an MG1E, which is what we're talking about. So in relation to the board here, in the bottom right-hand corner, this C and the H, that is again your 24 volt output to the actual blower motor. You have your blower motor up here at the top. You have your 1 through 5 speeds and then your line voltage on that. So other than the 24 volt output in the blower motor, really nothing has changed within the wiring diagram from the M1MB furnace. Just mainly how the blower motor is how it functions, and how it's set up. Now, in relation to troubleshooting, it's not going to be anything different than what we had talked about before. So again, all you have to do is verify low 24 volts and line voltage going to the motor. And if we don't have that going to the motor, then we may have a board issue. But if we do, then we may have a motor issue. Another question that we get in tech a lot is, how do we change the blower speeds in this new MG furnace? It's really simple, and I've already kind of touched on this before, but I want to reiterate that because we get a lot of phone calls in tech. Essentially, all you have to do is move your yellow wire or your red wire to a lower speed or a higher speed, and you do this directly on the blower motor plug. You do not do that on the board itself. So what I will say is, most of the time, your heat speed is going to be on tap number 3, and your yellow for cool is going to be on tap number 5. Now, a lot of times you don't actually need tap number 5 for your cooling, and you can lower that to, say, speed number 4 or speed number 3, just depending on how your heat kind of works out and what you need for on the heat side. But it's as simple as that, by pulling a yellow wire off and putting it on either a lower or a higher number on changing the blower speed. Okay, so what I want to just reiterate and bring attention to you guys is that you must set the blower speed to be within the temperature rise or temp rise of the furnace model. So when you are setting up your blower speed, and this is really critical because we're within the FER world now, if you will, is that you have to be within that blower chart parameters in order to be FER compliant. And what you also want to be looking at is what the max temperature rise is of that particular furnace model number. And it may change model to model, and then even within a model line, on the BTU side, it can be different. So on some smaller BTU models, it may be, say, 60 degrees as a max temperature rise, but on the higher BTUs, it may be 65 or 70 degree temperature rise. That information can be found in a couple of spots. One, it'll be on the data sticker that's on the furnace itself. The other place that you can find it is going to be in the tech spec, which you can look at on our online library. And we do give the temperature rise of that furnace in the tech spec. So again, it's going to change on the furnace line, and then it'll change a little bit maybe within the BTU line of that furnace. So there's not like an end-all number that I would give you, because there's a lot of variables and a lot of different parameters that kind of goes into that. But the main thing I want to get across is that we need to be within the FER compliant, and we need to set the blower speed to be within the temperature rise allowed by FER. So what I have here is I have blower charts from 2 different furnace BTUs on the MG1E line, the single stage 80% furnace. These charts are directly from the install instructions, and the main thing I just wanted to show you was the differences is that you can see that, for example, like your low speed, for example, on the 56,000 BTU, you can get away with using low speed. But once you get up to the 77,000 BTU furnace, you can no longer use low speed. And that's because your temperature rise is getting too high, and most likely what you'll do is trip the main air switch on the furnace. So what I really wanted to point out to you guys is that depending on what BTU you have, your cells on what you can set for your blower speed, that does change a little bit. So it's not like a one-size-fits-all deal on that. So it does change a little bit when you're looking at different BTUs on that. And then this is just going to be your cooling blower chart. So this hasn't changed from the residential side, meaning that your static pressure ranges from a 0.1 to a 0.8. We then give you the CFM number based on what your static pressure is. And then you also just have your furnace model number there. This is pulled from the 77,000 BTU number. And then you also, again, you'll have your alternate speed, which is tap number 4. So if you need to utilize that, we then give the CFM number based on your static pressure for the alternate speed. So that's a little bit of a refresher on the FER side. Hopefully you guys knew a lot of this already, but I just wanted to bring this up as we go into the heating season, and any questions that you may have potentially when you're installing the equipment or you're servicing the equipment. Hopefully I've answered some of those, so you don't necessarily need to call in a tech service, and you can save a little bit of time and fix that directly in the field. Again, you're more than welcome to call tech service, and we'll walk you through what you have in front of you. So throughout the presentation, we have been getting some questions, and what we're going to do is take a look at those questions and answer those for you. So any questions that you may have over the FER topic that we looked at, please submit away, and let's take a look and see what you guys got. And throughout the presentation, we've had some great questions come in over this FER topic, so let's dive into those questions. Again, any time through this Q&A session, feel free to submit any questions. Submit those to us, and I will be happy to answer those questions on this FER topic. And hopefully that presentation covered a lot of either unknowns or confirmed some things for you guys that were in the field, either installing or servicing the equipment. So let's get into your questions and see what you guys got. Okay, so we'll start off here. First question is, what is the blower alternate speed equivalent to? So is it like a medium high or a medium speed blower motor? If you were to look at that, say like on a 4-speed PSC motor. So really, I guess what you could categorize that as a medium high speed. Generally, it's going to be tap number 4 on that blower motor plug that is open. Like I said in the presentation, that alternate speed is going to be a little bit different per furnace model, along with the BTU on that furnace. So because that's all kind of getting more into the FER, and each furnace has a different selection speeds for your blower, depending on what your temperature rise is, and looking at those blower charts on the heat speed. Some cells are grayed out, which you cannot use, and other cells will actually give you your CFM number based on your static. So generally what I would say, what I've looked at is it's tap number 4, which if you want to have number 3 as your medium, 4 would be like your medium high speed, if you want to look at it that way. Another question is, heating chart only applies to the gas furnace operation, not heat pump heating charts. And yes, Dan, this is correct. So when you're looking at those 2 separate blower charts, which again, we had to separate those per FER, we couldn't have it in one chart. So your heating chart, if you will, which ranges on the static pressure of 0.1 to 0.5, that is for your gas side, your gas-fired furnace. On the other chart, or the cooling, is what I just refer to as your Y call. So always tell guys in tech service, Y is your compressor call. O determines whether or not you're in heat pump mode, if you will. So, so to answer your question, when you're looking at the CFM level and your static pressure relationship there, it's going to be on that cooling chart. So Y again is your compressor call, and then your reversing valve determines whether or not you're in heat mode or you're in cool mode. Another question here is, was the fan only call an FER requirement? It wasn't necessarily a fan call that was an FER requirement. What it was is just the overall efficiency of the blower motor that had to change, and there were certain guidelines as a manufacturer that we had to meet. And really the most easiest way to bring that change to you guys was to go the ECM motor route. A lot of manufacturers went that route, and we were one of them. But the fan only call is really just your G call. And again, on the wiring diagram and from the factory, the G call is going to be on tap number 1 on that motor plug. So again, you can move that green wire to any speed that you would want to if the customer is going to run the fan only call on that furnace, either all the time or intermittently, whatever they want to do. But the G call actually was not part of the FER requirement. It was more of just the motor itself and the efficiency on it. Another question here is the line voltage to the motor cycled or continuous? So the line voltage is going to be applied to the motor at all times as soon as you have power applied to the furnace, whether or not that's a switch on the side of the furnace or it's the actual breaker itself. So your line voltage, again, is applied to the furnace at all times. What brings the motor on is going to be the low voltage on the low side voltage of the motor. So you'll have your 24 volts that comes from the board, and then we'll energize speed taps either 1 through 5, depending on where your heat wire and your cool wire are at. But to answer your direct question, line voltage is applied at all times. What brings the motor on is your low voltage. Just another question here as far as diagnosing the motors that are going to be on these furnaces that you've seen over the summer. So the way to go about, again, just troubleshooting this motor is 2 things. One, confirming line voltage to the motor, and the second thing is to confirming low voltage to the motor. There is no actual diagnostic tool that you guys will need in order to troubleshoot these motors. Basically, when you have a call for heat or cool, you're just going to be confirming that you have one, line voltage going to the motor, which you should have again at all times. And then the second thing is you're going to confirm low voltage. So there's a gray wire that goes to that motor plug, and that's going to be your 24 volt common. And then depending on either what furnace you're working on, say it's manufactured housing, for example, it'll be a yellow wire coming off of that board that's going to the motor plug. And if you're calling for cooling, that yellow wire should have 24 volts on it. So it's the same type of troubleshooting as the package equipment with those X13 type motors. So there's no tool needed, which I guess is a good thing. It's something you don't need to have when troubleshooting the motors in order to troubleshoot those motors. So no diagnostic tool required. Another question here is, I'll just throw this out there. I bet some of you other guys are thinking the same thing too. FER in general, were condenser fan motors in that FER requirement? And the answer is no. So the condenser fan motor side is still going to be like just a regular PSC motor if you're on say a single stage piece of equipment. Some of the 5-ton units will have an ECM motor on it. And then if you get into the 2-stage stuff and then the inverter-driven units, that'll have an ECM on it. But as far as condenser fan motors go, those motors were not affected by FER. Another question here is, can you put an FER furnace board on an older unit? So, and the answer is no, you cannot. So, again, I just want to stress this to you guys. When you go to switch out a board, if we do indeed have a board related problem on a furnace and we need to replace the board, we need to, one, take the serial number down, because that's going to be very important when you go to the distributor and you ask for a board. The main reason for this is that the voltage output on that 4-pin plug in the bottom right-hand corner of the furnace board is different between, say, the old style prior to July of 19 to after July of 19 until today. So again, the old style was with the PSE motor, and that 4-pin plug was 120 volts output. The new board, or the current board, is going to be 24. So again, we always tell guys this when they call into tech service, because even on some other units, say like the B6 air handler, for example, we switched boards in 2017 where we went from a two board application to a 1-board application. In order to minimize confusion and frustration when you get the wrong board, serial numbers are really important when trying to get the right parts. So yes, so to answer your question, you cannot use an older board on a new furnace. Good questions, guys. So keep those rolling in here. Just another generic question here. Was there any components in the furnaces themselves that changed with FER other than the motor itself? So the general question, or the general answer to that, is going to be no. The board itself has changed a little bit, like I've said, as far as the voltage outputs going to the motor. But the other components in the furnaces, like your pressure switches, your limits, the gas valve, those other components on the low voltage side, they haven't changed. So the FER really just pertains to the blower motor itself, and everything else is the same operation as far as startup sequence on a furnace, along with just overall troubleshooting. So all of that is the same. Great questions, guys. Keep those flowing in here. Just another question on the E7 electric furnace as far as a diagnostic tool. Those motors are going to be your fixed torque ECM motors, so you will need that motor tester. As long as if you had like the B6 fixed torque ECM motor along with the variable speed, you would want to have that broad ocean motor tester. The motors that are going to be on the furnaces and well, really just the furnaces, is just going to be just a 2-pronged attack when you go to troubleshoot it, low and line voltage to the motor. So there's no actual motor tester that you would need again for that. But you would, that's a good question. On the other stuff, like the 2-stage G7 furnaces that are the variable and the fixed torque, in order to troubleshoot those correctly and efficiently, you'd want to get that motor tester for sure. Another question is here in relation to the temperature rise. And I'm assuming you're referring to the blower chart on the furnaces. So question states is, how many degrees above or below the numbers on the chart is acceptable for a temperature range? So you really want to be, I would say, I mean, generally speaking, it's going to be hard to really peg the temperature rise number exactly on that chart. So you want to be really close to it as best as what I can tell you. Obviously, if we have an airflow related problem and we're tripping the limit switch, we can't tell you to bump up the blower speed in order to get that temperature rise down. What you have to address is the overall airflow of the furnace. So that could just be one, the blower speed itself, making sure that's set properly and correctly per FER regulation. And then also two, stuff external to the furnace is going to be your ductwork. So a lot of times what we see on the phone in tech service, and then sometimes guys will send us pictures in, is just the overall ductwork plays a huge role in your system's efficiency and just the overall function of your furnace. And a lot of times when you're tripping a limit on the furnace, at least me personally, the first thing I ask is, what is your temperature rise going across the furnace? Because at that point, I can get an accurate CFM number and see if the actual static pressure that you're taking is correct or not. But just by using a CFM calculation on temperature rise, I can get a pretty accurate reading on what your actual CFM number is. So in general, if just get that temperature rise really close to that chart as much as you can, is what I would tell you on that. Just another question here, more of a generic question on FER. Question states, well, let me look at this here for a second. Basically, what the question is asking is, is there any other equipment that was affected by FER regulation that came onto the market last year? So the FER itself, or the FER package, was really directed on the residential furnace side. So it didn't involve any commercial equipment, at least to my knowledge. It's all going to be on the gas furnace residential side, is what the FER program that was given to us as manufacturers was directed at. So the only exceptions, and I did say this in the presentation, was one, air handlers were not affected. The primary source of an air handler is the heat pump versus the heater kit. So FER was not directed at air handlers, so you can still get air handlers with the PSC blower motor in them. The other thing too that I do get a question occasionally in tech is, why wasn't oil furnaces part of the FER guidelines? And the best answer I got for you on that, or at least what was told to me, is that just it comes down to a volume thing. So it's really just the amount of oil furnaces that were sold. It just didn't warrant that regulation would apply to oil fired furnaces. So it was all gas, natural gas, and LP furnaces that were part of this FER. So it's a good question, actually. But yeah, the oil side is still a PSC blower motor. So on the M5, for example, the oil-driven furnace on our manufactured housing side, that is going to be having a PSC motor on it. So yeah, just the gas side of the residential furnace side. Another question here is, do the installation instructions include a gas pressure adjustment for high altitude? It's not going to be, I guess I'll say this, there's not like a separate packet that's going to come in the furnace itself. All of that information is going to be in the install instructions for that furnace. So you'll have to look at what your elevation is. even if you're on natural gas, you'll have to take a look at the burner orifices and look at the BTU numbers on that furnace and make sure you're, within range on your altitude and what your burner orifices should be. The last thing that we want to hear in tech service is that we have a sooted heat exchanger due to a furnace that has not been properly converted over. That's normally not a very good day, so at least on the contractor side. So, but yeah, so all of that information still hasn't changed as far as where to find it at, and it's going to be in the install instructions that would come with the furnace. If you ever need that at a later date, you can go to our website directly, which we have a technical literature library tab on our homepage, in where we have all that information available to you guys, 24/7. Good question, guys. Go ahead and still filter your questions in, whatever I talked about on the presentation. We kind of did this FER refresher, mainly to, one, just update the Lunch and Learn PowerPoint from last year. But the other thing, too, is I wanted to give you guys, or at least an opportunity, a chance to, one, review the material, because you guys have seen it now in the field for a good amount of time, but then also to hit me with any kind of questions or concerns that you're either seeing in the field with this new FER setup. At least in tech service, our experience with the FER is going great. Not too many problems. I guess the one question that we do get a lot that I'll address here is on the new manufactured housing furnace side, the blower motors, the cooling speed tap is on number 5, which is the highest speed. So we get a lot of questions in tech, believe it or not, as far as can we lower that speed to a lower number? And the answer is yes. So the yellow wire coming from the furnace board to the blower motor, from the factory, we put on tap number 5. And really the main complaint that we get is that the fan is too loud, and is there any way that we can quiet this fan motor down? And so yes, the answer is just simply lower it to a lower speed. So most of the time you probably don't need it on tap number 5, but we put it there anyways just to make sure that, one, we don't want you to freeze the coil, and generally cooling is going to be on the high speed. So, but yes, you can lower the blower speed. Just wanted to throw that out there. Great questions, guys. Keep filtering those questions in. Anything over the PowerPoint, feel free to hit me with what you got. So another question here is, if the blower chart shows I should have a certain temperature rise, but I'm reading lower than this temperature rise, can I make further adjustments to that blower speed? And the answer is yes. So within the FER guidelines on that. So if you have like a furnace where you have the ability to go from speeds 2 and 3 on your heating blower chart, or sometimes you'll have access to speed number 1 as an option for the heat speed. So yes, if I'm understanding this question right, if you have a lower temperature rise and you want to gain a higher temperature rise, you can lower the blower speed down to get that higher temperature rise. The only caution I would tell you guys is retake your temperature rise once you lower that blower speed, because we don't want that furnace to potentially be cycling on the high limit switch. So yeah, as long as you're within those FER, those white clear boxes that are on the chart, you'll be good to go. Well, guys, I think I've answered all your questions on this topic, at least as of today. Not really getting anything coming in as far as questions on this presentation. I just want to thank you for your time, for tuning in today. And again, this was our Tech Service 2020 Fall Lunch and Learn. Hopefully, I will see you next year in the spring. I don't believe we have another Tech Lunch and Learn scheduled for the remainder of the year. We're kind of closing in as far as our timeline for Lunch and Learns on the fall, and we're getting into winter. And I know as the year's going to go on, everybody's going to get a lot more busy with the furnace calls and all of that. Obviously, we're very busy in tech every day, so can only imagine what you guys are dealing with in the field there. So again, thank you for your time, for tuning in today, and stay tuned for either quick tips that I want to be coming out with. If you guys have any suggestions to me directly, as far as what you guys want to see in those tips that I send out either on the eNora page or the YouTube channel, feel free to send in suggestions on either topics or stuff that maybe I haven't covered that you would like to see covered. I'm always trying to think of new things, new approaches that I can give you guys content that's relevant to your day-to-day operation and just help you guys overall in the job in the field and troubleshooting and installation. So I know we've done a lot of videos, but again, if there's anything that either we're missing or maybe topics that we haven't covered, feel free to send us an email, and that'll get directed toward me. So with that, I just want to say again, thanks for tuning in today. Hope you guys have a good rest of your day and stay safe out there. Thanks.